In this demonstration, we will illustrate the mining of different blockchains, how the block mining algorithms differentiate with one another, how they can affect the environment, and how Libonomy can outperform this by acting as a universal blockchain. We will compare the metrics of each blockchain, which mainly includes Ethereum, DodgeCoin, and ZCash. Also, Libonomy verification node, and how Libonomy can outperform these blockchains. The general idea behind Libonomy blockchain is that it means to act as a universal blockchain. Libonomy with Ethereum protocol, that means an AI-powered consensus engine, was invented in order to allow any commercially available system in the world to contribute and take part in the blockchain network. For more details about Libonomy blockchain, please read the white paper for a more technical understanding. You can also visit us on GitHub. For business details, please visit the Libonomy website. We're also on Discord, ready to help and answer your questions. Before starting, we'll show which computing machines we utilize. We do not utilize any ASIC chips and only use commercially available systems, GPU. That way we can run different mining blockchains and show how Libonomy can outperform. For a better understanding, the GPU we will utilize is Nvidia Tesla V100. Intended for machine learning with a 16 GB memory. We're going to utilize the model P32X Large. The virtual CPU is around 8 in this instance. The Tesla V100 card itself costs more than $7,000. Not something most people in the community utilize for their own home use. Instead, preferring Nvidia 1050 or 1080 Ti cards, and others available as they can be used for mining but don't give as good results as Ethereum blockchain based. On an hourly basis, depending on the community, this GPU is utilized to run ZCash and Ethereum mining. Ethereum cannot be mined on general CPUs. According to the current general network, hash rate is around 123 TH or terahash per second. The hash rate of ZCash now is 357 megahash, and for DodgeCoin the hash rate is around 302 terahash. We cannot utilize CPU as the hash rate is quite high and Ethereum miner does not allow CPU mining. Therefore we have to utilize GPU for that purpose. As DodgeCoin allows CPU mining, it's basically a hybrid mining algorithm which can utilize CPU or GPU mining, which is normally regarded as ASIC resistant. But that's not true. It is technically based on proof of work. Other than that, for DodgeCoin, we will be using T2X Large instead of AWS. It contains 4 virtual CPUs, 16 GB of RAM. To run the Libonomy blockchain verifying node, we use T2X Large with 2 virtual CPUs. Now we switch over to the DodgeCoin mining console. Over in this left column, you see the DodgeCoin mining result and how the system is performing. Here the process conception is highlighted, and in this column we'll see different processor conceptions being made and how much conception DodgeCoin is having for us. As mentioned before, T2X Large contains around 4 CPUs. Similarly, in this third right column, you can see our 4 virtual CPUs are being fully utilized. So there is no available resource in order to carry out any extra process. That means you are consuming the whole processing speed that your system has. This machine is not cheap. Although commercially available, and most systems include this kind of processing speed, if you are running a mining node, your whole system is being consumed with no other free processor available where you can run and carry out any other task. So the main problem, as it's based on proof of work algorithm, so that's the major issue. Although some miners do allow you to utilize some algorithm, which will restrict the CPU usage, regardless, you will still be unable to contribute to the network. This is the major problem in terms of DodgeCoins. This is the CPU usage we are seeing. We'll also highlight the sources our system has. This is the information regarding the CPU, which is here, and the number of virtual CPUs, which is 4. Above that, the instances is highlighted here. We'll also highlight memory usage for you to get a better idea of. Here is our memory, and this is our usage of RAM. This is in terms of DodgeCoin. Now, we'll switch over to Ethereum. As mentioned earlier, Ethereum cannot run on regular CPUs, so we have to utilize GPUs. And one important thing regarding the effect of high processing speeds is that there is a heating issue. Due to the heat dissipation, it can reach more than 90 degrees, but this all depends upon your heat control and whether you have any heating limits. As you are consuming a high processing speed, it is up to your PSU. The use of electricity can increase up to 800 volts or more based on an average monthly basis. Now, we'll look at the logs of the Ethereum mining node. This column here on the far left shows our mining information, where we are connected to Ethereum mining pool, and where we contribute and mining or validating blocks. The second column, you see the information regarding the Nvidia graphics card. Here it shows us the temperature and electricity consumption. In the third column, like previously, we will see the CPU usage. In terms of Ethereum mining, we have restricted the usage of our system so as not to overload it, and are using one virtual CPU. As you can see, it's at 100%. That means the whole CPU is being utilized. You can also see the live consoles here, where you see the metrics. According to the information provided by the network, the user's CPU usage increases or decreases. So 70% of the CPU is being used by the network. If you have more, the higher the percentage. If you have more core usage, then in turn we can utilize more cores. It all depends on your mining configuration. In this center column, you can see our temperature. Right now, you can see the temperature is around 66 degrees. Next to that, you can see the electricity usage is around 224 volts. For the sake of the video, let's say the mining uptime is about 10 minutes. If we let it run for one day, a week, or even a month, it will have a negative effect on your resources, as POW is regarded as resource intensive. The purpose of this video is to prove whether or not they are resource intensive and how bad they are for the environment. Another important note to highlight before we forget: even though you are utilizing the whole resource of your system, in other words, consuming high electricity, they are not only bad for the environment, they can be costly. As for normal community members, it does not mean they get a reward from it, as the network hash rate is quite high, and your hash rate is around 90 megahash per second, which is just here. Due to that, you will not get any revenue, but instead be spending an extra $500 here. This is just an average, but you can see the mining reward calculator available on many websites to get a better idea about it. The main purpose regarding energy consumption you can check right here. As we highlighted earlier, Tesla V100 was meant for machine learning, not for mining purposes. Right now on Ethereum, if you wanted to get a high reward, you need to utilize ASIC chips that are not only costly, but also consume a high amount of electricity, as evident by which we have high carbon emissions in the environment. Due to this, you are not only affecting the environment, but also living things in the world. Ethereum and other blockchains are working, but they are still behind, and due to this issue, we have problems where the blockchains are not being accepted by many organizations and countries. So we have seen the CPU usage and how much electricity is being utilized. So let's say we disconnect from the network. You will see the whole usage has been lowered. Even the electricity consumption has come down to 32. This means your system is in an idle phase. You can see the negative effect not only on our system, but to the environment. Now, we'll switch over to DodgeCoin and close the mining node here. As soon as we close it down, you see the whole processor usage is free. The issue with DodgeCoin exists here. Even though they allow CPU mining, what is the benefit if you were just wasting your system's CPU and resources and having to spend extra money to run your system? We'll shift over to our ZCash. You see our mining node isn't running, so we'll just activate that node now and connect to the network. Let's say we need to see our system resource. So we go to the resource terminal and you see what we are using. As highlighted, ZCash needs to utilize GPU, so we utilize the same GPU here. Nvidia Tesla V100 and AWS B32X large, with 8 virtual CPUs present. We have restricted the ZCash miner to utilize only one virtual CPU so that we don't put extra strain on the GPU. In terms of ZCash, we have already seen the hash rate of ZCash on the network right now, which is 357 megahash. If you were to utilize a decent GPU like the Tesla V100, which was built for machine learning, you will still only get 971 sols, and 971 sols per second means you are getting a hash rate of 971 hash per second, not megahash per second. Even though we have a graphics card costing more than $8,000, we will not get any reward. We will, in fact, be wasting more than $1,000 on a monthly basis, on top of high electricity usage and high heat dissipation, which has a negative effect not only on the network, but also the environment, and to our system, as daily processing requires a cooling mechanism to properly function and not overheat and burn. Here you can see our CPU usage is at 100%, and we still get no reward from it. So what is the use of having a high processing system if you don't get the reward, but are spending extra time and money? In general, you are not contributing to the network, but the network is taking the load from you. This was not the concept for blockchain, neither what the blockchain was intended for. This removes the concept of decentralization, not due to the concept of technology, but because of the use of technology and how it is built. You can easily see the issues in the system. Now we'll switch to Libonomy and show you how Libonomy outperforms them. We are running the Libonomy Verify node. The minimum requirement in order to run mining or verify a node on the Libonomy blockchain is around 4 GB of RAM, and Libonomy blockchain is ASIC resistant, which means you cannot utilize ASIC chips. If you have ASIC chips, they will be useless. The Libonomy blockchain was intended for normal systems and commercially available systems, so any node in the community can join and contribute, either by acting as a validator node, where they can verify and mine the transactions on the network, or they can be utilized for providing the network speed. Most of the time, systems don't have a good specification, but they do have a good network. So here in Libonomy, using our multi-pooling algorithm, we allow the use of artificial intelligence, as highlighted for machine learning. But not only that, you need a good computing system, which we also solve that issue by coming up with the concept of decentralization, or blockchain solution, but decentralized artificial intelligence, where artificial intelligence algorithm don't need to run on a single system. They run on a cloud platform. For more information on that, you can read our white paper or visit our website, where we will be releasing new demonstration videos for you to get a better idea about us. Regarding Libonomy, right now we can see that the console is showing 2 virtual CPUs, and just to list them, you can see, as highlighted for Libonomy, we are utilizing the T2X Large Amazon instance, where you see 2 virtual CPUs and 8 GB of RAM. Also, just to point out, all these networks are mainnet, ZCash, Ethereum, DodgeCoin, and Libonomy all run on mainnet. Now you can easily verify. This is the main thing Libonomy is providing to the community. Your system won't affect the climate, you won't affect your environment, your system won't affect anyone else. Your system will no longer contribute a negative impact, but instead will help the network to grow and sustain. Here you can see 2 virtual CPUs, and here you see CPU 1 is only 1.5% utilized, and CPU 2 is around 0.5% utilized, and still run any application you want, and it won't affect the network in any way. If you have a high computing system, your Libonomy will run in the background with no effect. This is our proof that we can easily verify the Libonomy blockchain, and how this can act as an efficient system in the community, and how the community can benefit. By using the consoles, you can get a better idea of the system, and in the next demonstration we will be showing a comparison between other popular systems. As of right now, Libonomy is the only one in the community that allows any computer in the world to contribute, in a true decentralized manner, and also with the concept of decentralized AI. We will also be reviewing other systems and comparing them to Libonomy. We hope this demonstration was useful to you, and you have a better understanding of what we provide.